All right, good morning, everybody, and welcome. We want to thank you for being on this webinar today. We really want to thank Mr. Gent, Dave Gent out of Washington, the APA up in Washington, and he is going to present this. But before we get started, a little bit of housekeeping. The screen that we have up right now is the webinar sponsors that we have here in Colorado from the Rocky Mountain Asphalt Education Center. These are our sponsors that help us to keep these webinars at no cost for those of us here in Colorado and around the country and around the world. We do have some people on that registered from other parts of the world. So we want to thank you all for being on today. We want to thank again our sponsors. One of our big sponsors, the APWA Colorado chapter and the Colorado Association of Road Supervisors and Engineers, which is the county version of APWA. We have a couple of our producer contractors, Schmidt Construction Company out of Colorado Springs and Castle Rock, and Colorado Asphalt Services of Cassie. They are here in Commerce City, the Denver metro area, and they also are the makers of Easy Street product in Colorado. Vance Brothers, a maintenance contractor, A1 Chip Seal, another maintenance contractor. The Municipal Government's Pavement Engineers Council, which is the Denver metro area and now spreading out across the state. They have created a local agency specs that are really geared for local agencies, that we're not using the state DOT spec to build our local roads, and that's what their function is. And then Benvix and Black Magic. So I need to thank all of them for being on today and paying those sponsorships to keep these at no cost. I want to thank everybody for being on. And Dave, if you want to go ahead and start sharing. Mr. Dave Gent, like I said, is from the Washington APA, the executive director up there. And I'll let Dave go ahead and do his own introduction. Dave, it's all yours.
Okay, let me just make sure I can get this sharing started. What do you see on that end?
Still seeing my stuff right now.
Okay.
You're gonna have to go back to that share again. That
share. I'm sharing this. Sharing the PowerPoint and share and
there you go.
How about now?
It's coming up. There you go. We got it.
Okay. Good enough.
I'm going to interrupt you for 1 second. Sorry, I forgot this. During the webinar, if anybody wants to ask a question, you can unmute yourself and ask the question, or you can type your question into the chat window. The chat button is on the lower right of the screen. So you can type your question in there. I will either hold them, or I will ask at the time. I'll interrupt Mr. Gent and ask that question. So sorry, Dave, go ahead.
No problem. All right. Well, good morning, and thanks for your interest in this topic. I'm very involved in it, kind of nationwide, and hopefully let you know exactly kind of what's going on with the perpetual pavements across the country. So this is titled "The Use and Success of Asphalt Perpetual Pavements," and I'll kind of go through both view of that. But anyhow, a little bit about me. I'm nearly a lifelong resident of Washington State. Grew up in a small town in the center of the state. Moved to Seattle to attend college and have lived on the west side of the state. And we'll talk about east and west here in a few minutes for 45 years now. I earned my bachelor's degree in civil engineering from the University of Washington. And during those studies, I managed to get a job as a research aide in the asphalt lab. And the rest is history. I've been involved in testing, production, and paving ever since. I worked for 32 years as an estimator, project engineer, project manager, operation manager, vice president of heavy highway civil constructors, 20 years for a family-owned company in North Seattle, and then another 12 years for a CRH, the far western outpost of the CRH companies south of Seattle. I joined the Washington Asphalt Paving Association as its technical director in 2014 and became its executive director in 2016. My main hobby is motorcycle touring with my Moto Guzzi V85 TT, where I'm constantly performing up-close pavement quality evaluations. Okay, let's see here. Get that started. So a quick, this is kind of what we're gonna, the agenda for today. Let me get something on my screen here. A quick view of the Washington Asphalt Paving Association and Washington State's construction-related profile. The use part of this presentation is what are perpetual pavements and what's the Asphalt Pavement Alliance. Washington State's traditional by-performance perpetual pavement awards, the evolution of pavement design, and the emergence of understanding endurance limits, and the per road tool for pavement design evaluation. The success is the recent expansion of the perpetual pavement awards to roads designed and built in the present day. So we have both design and by conversion awards now. And I'll show you a couple examples, then we'll have some questions if we have time at the end, or as Tom said, you can ask questions in the question box as you need to, and he can interrupt if he'd like to. Okay, this is being a little clunky. Okay, major attributions for the content of this presentation is Dr. Dave Tim from the National Center for Asphalt Technology. You'll hear me say NCAT several different times during this, and that's just what I just said. That's at Auburn University. He's also a civil engineering professor there. And Amy Miller, she's our national director for the Asphalt Pavement Alliance, which I will explain a little bit further on, and also the vice president of industry alliances for the National Asphalt Pavement Association. Again, I'll use NAPA several times during the presentation. So the Washington Asphalt Paving Association is a single point representative. We were founded in 1954 before NAPA was even organized. All of WAPA's producing members are also NAPA members. So we are really invested in fully supporting state, regional, and national advocacy. Washington Asphalt Paving Association represents the 15 companies and approximately 66 asphalt plants that manufacture 98% of the asphalt mix produced in the state. Those same companies also are contractors, so they construct 98% of the public works pavements in the state for states, ports, etc. So WAPA is the single point representative for the asphalt pavement industry. We work extensively with our Department of Transportation and with any and all other stakeholders with respect to asphalt issues, especially with local agencies, public works. We are also closely work with the American Public Works Association chapter in our state to maintain the local agency specifications that may differ from the state DOT specs. Much like CAPA, we are we also are the lead in annual training programs, and we're the industry liaison for legislation and agency regulation. Just a little bit about Washington real quick. It's kind of a tale of two distinct regions, Western and Eastern Washington. Despite what you might hold in your head as what Washington looks like, it's a pretty variable state. And those variations kind of define how our pavements are done too. So Washington's got a very complex topography, kind of like Colorado, but we're kind of dominated by the Cascade Mountains here. The Cascades really tend to define the character of East and West. We're quite a bit smaller than Colorado land-wise, land area about 71,000 square miles, where Colorado is 104,000 plus square miles. But we've got, the Puget Sound that kind of divides the state too, but really the designator is that line down the ridge of the Cascades. This kind of shows you the same thing. It illustrates it a little bit differently. These are the political boundaries of the counties, and again, they basically follow the line of the east and west, the line of the Cascade Mountains. So our state population is 7.71 million. Western Washington is more urban. It's got over 6 million of the folks, or 78+% of the population. A lot of rural character just outside the population centers, dominated by industry, seaports, tech that underpin and drive the economy. Boeing, PACCAR. We've got the ports of Seattle and Tacoma. Of course, we've got Microsoft and Amazon and Starbucks. And some of the older line industries like Weyerhaeuser are still centered in Western Washington. We've got more modest seasonal changes and much more rain on the west side, roughly an 8-month paving season, mid-March to mid-November, but we lose a lot of days to rain during that time. And we use the dominant asphalt binder on our side, on the west side of the state, is PG58H. That's a massacre designation, which is basically PG 64 minus 22. On the eastern side of the state, it's more rural with agricultural base, apples, potatoes, wine, and wheat. It's very arid with hotter, drier summers, and in the last 5 or 6 years, that means wildfires that choke the whole state sometimes for weeks on end. Much colder winters and much more snow. They've got about a 7-month paving season. Many miles of chip sealed pavement because they've got a lot of rural farm to market highways and county roads. And they use PG 64H minus 28, which is roughly equivalent to PG 70 minus 28. So that kind of, I think, gets you, this road miles. This shows that the lane mile makeup for the state highways only. As you can see, I'm not here really to tell you that Washington roads are somehow in any way superior to any other well-run state like Colorado. We have roads that have stood the test of time, which we're going to talk about today, but often because they've been properly maintained. But chronic underfunding of our system is really catching up with us now, and we're in danger of losing adequately designed highways that are being structurally compromised due to lack of timely preventative maintenance. This is a good reason for us to tell the story about perpetual pavement. To show that with proper preservation, they will serve the state well through many decades and generations. We want to spread that message and highlight it for legislative bodies that don't like to spend limited resources on boring stuff like pavement maintenance. You can see that our hot mix asphalt paved streets, 9,000 miles, highways, this is all DOT highway miles, 40% are either due, past due, or far past due for maintenance. Our chip seals are even worse shape, 7,300 miles of chip seals, almost 73% of them are due or past due. And the concrete pavements, which are really urban highway pavements, about 25% of those are way past due. So we've got 52% of our system is far past due, or due for maintenance. So what is the Asphalt Pavement Alliance? That's what we've kind of got to start with, or we're going to talk about perpetual pavement awards. The Asphalt Pavement Alliance, I'll say the APA several times, is the coalition of the Asphalt Institute, the National Asphalt Pavement Association, NAPA, the State Asphalt Pavement Associations, the SAPAs, and it serves as a trusted resource. The Alliance strives to establish asphalt as the pavement of choice by detailing proven advantages of asphalt pavements in the areas of safety, value, speed of construction, adaptability, performance, and environmental resilience. The APA is really a slightly separate entity that can represent all of the big three primary asphalt pavement associations in the U.S., and it coordinates marketing and collaboration between these groups. One of its first mandates was the Perpetual Pavements Recognition Program, which started in 2001. It helps to direct research and then supports rollout of the results of the research and tools developed. Pave Express, if anyone on the line is using Pave Express, I encourage you to do so if you're not. It's one example of the many successful endeavors that the APA helped lead. Expanding the Perpetual Pavement Program is a recent initiative, and that's what we're kind of talking about today, the success part of the presentation. SAPAs, I'm a SAPA, Colorado's a SAPA. SAPAs are the state asphalt paving associations. There are 40 SAPAs across the country in 39 states. California currently has 2 SAPAs. The state asphalt paving associations are professional membership organizations that bring together all the state asphalt associations that individually supported individual states. In states across the United States, these SAPAs are building relationships with asphalt producers and suppliers, local and state transportation leaders, and the public on behalf of our industry at large. So that's the SAPA part of the triangle. And here, the Asphalt Institute, I suspect everybody's pretty familiar with the Asphalt Institute, but it's an international trade association of petroleum asphalt producers, manufacturers, and affiliated businesses. It was founded in 1919. The Institute members represent 90% of the liquid asphalt binder produced in North America. So the Asphalt Institute is the binder supplier association, essentially, but they've been around for 100+ years, so longer than all the SAPAs and the National Asphalt Paving Association. So they ended up being the leading authority on hot mix asphalt well into the 50s and remain very strong, and now a strong partner with the SAPAs and NAPA. They still play a key role in asphalt pavement specifications, research, and expertise. They have 8 very well-versed regional engineers. You can see the regions here, and they've got one in Canada. She's she's something else. She's got a lot of ground to cover. They supplement the SAPAs and NAPA where needed, and especially in critical states that don't even have a SAPA. And there are several states, you can see in the West, there's several states that don't have state asphalt pavement associations, and a few in the Northeast too, and Alaska. So perpetual pavements. Through the Asphalt Pavement Alliance, the industry came together in 2000 to identify long-serving pavements to highlight the long-term value of asphalt pavements that were designed and built appropriately. Remember, back in 2001, super paved mix designs were very new and not widely accepted yet, and the predominant pavement design tool was AASHTO 93, done with nomographs, etc. The asphalt binders were non-polymer binders, usually best fitted to states' individual needs and best informed by the Asphalt Institute's old penetration or aged residue grading systems. We've traveled a long way in the past 20 years, but prior to that, there were a lot of great pavements built that both deserve recognition, and this is the APA's mandate, deserve recognition for their superior performance, and secondary, but actually became a very key role. They could help industry examine what the best of these long-term pavements had in common. Why did they last so long? The APA Perpetual Pavements in Washington State were all originally by performance awards exclusively, which is the truth for every place in the country up until last year, featuring our varied challenges in varied locales. The Washington State Department of Transportation has highlighted successful historic asphalt pavements through the APA Perpetual Pavement Program, with 7 subsequent by performance awards, with at least one award intentionally successfully nominated within every region, operational region in the state. So our state map, the state DOT has 6 operating regions, and as they put these awards for perpetual pavements by performance forward, they intentionally look for pavements in each of the regions so that each region could be recognized that they all build good pavements. So as of from 2001 to date, there's 164 awards that have been awarded across the country. You can see the map here. Washington State has won 8 to date. Every climate zone and traffic classification is represented from across the countries. And really, the states that haven't earned perpetual pavement awards likely just have not applied for awards, perhaps due to the difficulty in assembling the necessary 35-year-old records, which can be a little bit of a challenge if you don't have a great pavement management system in the state, or you don't have someone interested at the state DOT to gather that information. But you can see that some states were early. Tennessee, Minnesota, Alabama, Florida started early and have gotten them often, and a lot of other states have come in a little bit later as the program has been better promoted by the APA. So what is a by performance perpetual pavement? Minimum of 35 years of service life, so it's proven by performance. Minimal structural improvements over the pavement service life, not more than 4 additional inches of structure in the last 35 years. Resurfacing infrequently, not less than 13 years before overlays, and no deep structural distress. Only surface remedies needed to maintain the full functionality of the pavement. These criteria were used by the APA to determine award winners for legacy pavements that have proven that the structural design was designed and built to meet its intended function. They need to have been in service again for 35 years. The pictures here are just examples of what we're trying basically to avoid. Pavements that have bottom-up fatigue cracking. We'll talk a little bit more about that later, but that would be a structural failure, and so that road would not be a perpetual pavement. Or pavements that have excessive structural rutting, which is a little different than surface rutting, but rutting that happened because of the deep structural support is not adequate. So Washington's, I'll just highlight our 2021 by performance award-winning pavement, mostly because it doesn't have to be a high-profile pavement to be a perpetual pavement. This is a 4-mile plus section of State Route 7. It has an average daily traffic of only 1,971 with 9% trucks. But it has been open since 1952, and it's experienced 1.1 easels in that time. This million easels in that time. This route is often used by outdoor enthusiasts on their way to Mount Rainier. You can see Mount Rainier there in the picture. And it also leads to one of our 3 main mountain passes across the Cascades. Note that this award-winning project is not particularly, this is not a particularly unusual road. It's just a 2-lane highway. It was constructed with good materials, using the best techniques, designs of that day, and was built to handle a fairly modest level of traffic. But the highway has been in place for 70 plus years. It's only required very periodic surface preservation, and it's still fully functioning for its intended design. There's no reason to believe that it will ever be structurally compromised if the traffic loads don't increase dramatically, if timely maintenance continues and if Mount Rainier doesn't erupt. This example is the definition of a perpetual pavement by performance. It's proven its design over 70 years of service. Just a real quick, the pavement structure consists of 3 inches of asphalt, concrete, Class B, are an old spec for 5/8 dense graded mix with AR 4000W asphalt binder originally, over 2 to 5 inches of crushed surfacing, over selected untreated granular material. So they basically reshaped the road from its original design over some gravel barrow and built this 3-inch pavement over the top of it. In this region of ours, this is just a more close-up picture of the design of the time. In this region of our state, we're very fortunate that we have hard, clean gravels. So the salvage material used on the bottom from the select barrow through the crushed rock layers and as incorporated into the pavement are all superior quality rock with respect to highway construction. This great aggregate made even washed-out pavements, early washed-out pavements, very durable when designed correctly for the traffic and underlying soils. We didn't always get it right, but the vast majority of the original highways in the state have survived pretty successfully when maintained properly and when upgraded as traffic loads have increased. On this particular highway, traffic loads have remained modest, and with recent 20 years of restrictions on timber harvesting, it may even have declined a little bit on equivalent axle loads because there are fewer logging trucks in the area than there had been 20-25 years ago. So the last major rehab on SR7 occurred in 2005. It consisted of a 1500s overlay, 1.8 inches. The Class B 4000 AR 4000W was an outdated design. WashDOT currently uses a 1/2 inch or 3/8 inch HMA hot mix asphalt with PG binders that I talked about earlier. In this case, back then we were still using the PG, the newer PG, at that time new PG grading of 58-22. Averaging surfacing interval is almost 18 years in the history of this road, and the centerline rumple strips have been installed for safety. That's really the only upgrade that's needed since 2005. One of the keys to the successful application for a perpetual pavement by performance nomination is knowing the history of the pavement. WashDOT's has very good historical records through its pavement management system. This section, we talked about that. This section of roadway has an average resurfacing interval of almost 18 years, as you can see by that chart. It's also received less than 4 inches of increased pavement thickness over the last 35 years, which is criteria for perpetual pavement. Any notable spot maintenance occurred when the new overlay was placed, and due to the high performance of the HMA layers, coupled with relatively low ADT levels, very little additional maintenance has been needed on this stretch of SR7, other than minor crack sealing performed between contracts. That's a picture of our by performance winner for this year. These photos show that it's just an average rural highway that's performed its job well for 70 years with nothing but timely surface rejuvenation via thin lift overlays. So I think it looks pretty good for a 70-year-old whose last facelift was 17 years ago. This road hasn't been touched except to mill in a shoulder and centerline rumple strip since 2005. The surface still looks pretty good shape, likely another 5 years until another mill and fill is performed. We may well be witnessing the advantages and improvements and extended maintenance windows that are going to be garnered by using modern PG binders and super pave mixes, because we've got 17 years and another 5 years, I think, before it's needed again. In Washington State, we're obligated to perpetuate the national perception that it's always wet here, but it does dry out once in a while. So here's a dry picture of the mountain highway SR7 on a dry day. And so we try to make a big deal of these Perpetual Pavement Awards. Here's a close-up of the awards stage at our WAPA annual banquet in last November. Note for future reference that there are 3 different types of obelisks on the stage there, and we'll talk about. That's part of the success portion of our discussion today. So here's a picture and the reason I'm going to show these pictures is please notice who's in attendance except in the awards. Our Secretary of Transportation, the WashDOT Assistant Regional Administrator, the WashDOT State Pavement Management Engineer, and then this other guy. This just shows how special it is to highlight good news in the industry and with our Department of Transportation partners. Also note that the WAPA representative is on hand. I'm on hand and not the contractor. This road is 70 years old and it has been worked on by 4 separate contracts and 3 separate contractors over the years. It's nigh impossible to recognize the combination of contractors that built the highway and maintained it. This is small disappointment in the award's value, as it recognizes work that's really the work of long retired folks. So another reason that we're going to go forward with Perpetual Pavement awards that are going to expand. I think these Perpetual Pavement Awards show the early dedication to designing roads so that they fail from the top down, from surface issues, and not structurally from the bottom up. There are very few asphalt roads in our state anyhow that are being totally reconstructed. So these early robust designs have been critical for the long-term preservation of our pavement assets. This is one of the top legacies of the early design engineers. The average life of the WashDOT Perpetual Pavements by Performance Awards earned to date, and there's 8 of them, is 54 years old. And the new WashDOT highway, so in context, a new WashDOT highway being built today to WashDOT's current design parameters and mirroring the SR7 success would be receiving the same award in 2092. So it's a pretty good story to tell. I'd just add that milling and filling technology, which is also, only 35 years old, and nighttime paving, when it's justified, means that rapid surface renewal with very little inconvenience to the traveling public when these highways need a new surface treatment. In Washington State, surface renewal is often necessary because we use studded tires in the state. That kind of accelerates things. I think that the average surface life of a super pave mixes will be a lot closer to 25 years if no tires aren't used. Right now, we're statewide averaging about 18 years between maintenance overlays. There's a long line of WashDOT folks entrusted to keep these critical legacy highways in perpetual state of good repair. Highway contractors work with the DOT every day to efficiently fulfill this legacy, and I'm sure that's the same is true in Colorado. I'll just highlight a few more of these it'll become apparent why just below, but there's another 3 of the award winners built in 1970. This is in Alabama, US 72, built in 79. You can see the very layers of how it was built: select soil, aggregate base, and 8.5 inches of asphalt concrete. Got its first mill and fill and chip seal and overlay in 1993. Then wasn't touched again until 2006. Got a mill and fill, then again milled and filled in 2020. So that adds up to only an increase of about 2.5 inches since the original design. So again, it's a perpetual pavement by that definition. In Pennsylvania, they do it a little differently, but kind of come up with the same history. A highway built in 1965 with very low easels. As you can see, that the Alabama had high easels. Again, this is a very low easel highway in Pennsylvania, and over 18 years between rehabilitation intervals. Again, 56 years old, fairly modest highway, but it's a perpetual pavement and it's still performing after all these years. Here's one in Texas. The difference here is they've got a lime treated loam clay subgrade, so they enhanced the subgrade when they built it originally. 23 inches of crushed limestone, 8.5 inches of stabilized asphalt base, which is asphalt treated base, I'm sure, and then just a wearing course of 1.5 inches originally. And you can see how it's been upgraded over the years. One of the upgrades were really done just because of additional traffic load for the NAFTA agreement in the late 90s. And that's a 60 million Easel Road. So really, I wanted to show that this quickly shows that of the 13 by performance awards side by side, well, I just wanted to show the 13 awards that were awarded this year side by side. Shows a large variation in traffic loads on these pavements. And while 13 states were awarded by performance awards in 2021, Washington was the oldest of the crop, 69 at the time that we were that had accepted the award, 70 years now. This table illustrates that many variations of existing roads designed in a wide variety of climates, soil conditions, and traffic loads can be highlighted for their successful designs that have been proven by actual use over the intervening years. For the public agency folks on the webinar, I'd urge you to consider putting a small amount of time into highlighting your historic pavements for recognition by the Asphalt Pavement Alliance. Your state Asphalt Pavement Association can help you get that nomination in. So now we're going into that's the use of the Perpetual Pavement Awards, recognizing roads that are holding up well over many decades. Now, part of the success is we want to actively recognize and promote perpetual pavements that are being designed and built, in the recent time frame, so that we can kind of honor the people who are actually designing and building them now, rather than just historic models. So how do we do that? The concept of by design and by conversion awards. These new awards are at the confluence of modern pavement design and limited strain calculations that, when evaluated, allow for the expansion of the Perpetual Pavement Award Program to promote pavement constructed with the long view fully considered. We've recognized old superior performant pavements, but what have we learned from these by performance APA perpetual pavements? Again, this is one of the reasons we're going from use to the success. You'll see that this program has actually become integral in validating newer pavement analysis. And how can this information promote optimum structural pavement design today? So in the pre-1950s, basically we were mainly designing pavements based on experience. There wasn't a uniform design standard used in the U.S. Most of the conventional perpetual pavement awards that we're awarding today were designed in this era. In the 1960s, ASHO at that time, the road test provided national design standard. It was an empirical and design standard based on conditions at the ASHO road test. Despite its limitations, it's been used by the majority of states ever since. The first edition was published in 1962, but it's been refined by experience and results over the years. In the 1980s, we recognized a need to, or the possibility of moving into a more mechanistic design standard. We'll talk about that a little bit going forward, mechanistic imperial design standards. The concepts were well developed in the 1980s, but the computational power to the computers needed to do it efficiently was lacking, or were lacking. And then let's see, in the 1990s, the NCHRP 9-38 study was done. It was meant to create the 2002 ASHTO design guide. It's now called the Mechanistic Empirical Pavement Design Guide, or MEPDG. It's usually called ME analysis for short. And the company software, the ASHTOware Pavement ME design software is available. One of the big limitations with the MEPDG is that it needs local calculation that is expensive and time consuming and complex, and it doesn't always, so if you don't do those kind of local calibrations, you don't necessarily come up with any better pavement design results, and it's an expensive software. So it's not as widely used as it probably could be. In the 2002s, many states working on implementing this MEPDG, but over half of the states still use the AASHTO empirical system. It's now AASHTO 9398, or our state uses a version called Darwin, but they're all the same design criteria. The the APA award program began in 2001, and it's about time, and about that time, it started to help pave the long road towards a design system that could intentionally evaluate the design parameters required to build perpetual pavements. And that's the main focus of the success part of this presentation. So structural design. You start with the subgrade. What's the support, the susceptibility to reduce strength due to moisture or expansion? Then you add the traffic on top of that, equivalent standard traffic loads. We bring in the variations of climate, moisture, freeze thaw, hot and cold extremes, and then the materials that you use to actually build a pavement. What impact do they have? What structural attributes do they have when you're building the road? And what we're trying to do with the modern tools is optimize these layer thicknesses so that we're designing perpetual pavements, but not over designing them. The goal, regardless of the design system used, is to arrive at an optimal set of layer thicknesses that meet the needs of the subgrade, traffic, climate, and performance expectations of materials being incorporated into the project. There's many examples, because of this by performance awards, we have many examples and documentation of what has worked. Over 160 awards in 32 states. Many successes have been achieved through this conservative designs, the older empirical-based design systems, or just experience-based design systems. We needed a design system to analyze and get to optimum and economic pavement structures, compute maximum layer thicknesses for design consideration conditions, and consider and we wanted to add considering what we do with existing pavements that need structural improvement or rehabilitation. The existing Perpetual Pavement Award winners were likely a combination of over-design and good construction, and they gave researchers good information to continue to refine design standards. We need to continue with this good construction, but also optimize the road section using modern design approaches. We need a system that will tell us when the layer thicknesses are thick enough. AASHTO empirical and MEPDG do not directly have a mechanism to determine maximum effective thicknesses. So we need a system that can handle structural improvements, and we need a system that can handle structural improvements to a road that's going to be rehabbed from an existing pavement. So how can we use our evolution in pavement design to supplement and enhance current mechanistic and empirical design systems? Researchers ask the question, what makes a pavement structure perpetual? How can our well-understood design methods evolve and be enhanced beyond simple design life models? The answer is limited strain endurance limit models. So if we have indeed evolved in our understanding of the pavement design beyond just experience, how do we use this understanding and the critical factors necessary to design a perpetual pavement? In comes the concept of using strain limits for pavement analysis when the development and then the development of a program called PERROAD, a design tool measuring stresses at the bottom of the pavement structure. So this is actually a cross-section from the trenches at the National Center, from a cutaway at the National Center for Asphalt Technology in Auburn University, and it illustrates the problems that perpetual pavements strive to avoid. The picture on the left shows a classic bottom-up fatigue cracking. I'll show you better pictures, a little bit better picture, but there's a fatigue crack there that I'll show you a close-up. So bottom-up fatigue cracking happens where repeated flexure under loading causes tension at the bottom of the asphalt pavement section to initiate and propagate a crack from the bottom that comes up to the surface, so bottom-up crack. When this happens, the only real fix is to remove and replace the AC because it's structurally not keeping up with the load. The picture on the right kind of zooms in on the deep structural rutting in this Napa end cap pavement. Though there's excessive and obvious rutting at the surface, you can see if you look real close that between the wheel paths, you can see a lot of upward movement of the base pavement. So this is being pushed down, and the base pavement is moving upward, and this indicates deep structural rutting, which is different than material rutting. It's the actual pavement structure is rutting. Perpetual pavements do not experience either of these failure modes. So a closer look at bottom-up fatigue cracking. So this layer of asphalt or layers of asphalt, in this case, what is called 4 lifts, because of the flex that's happening at the bottom of that layer between that and the subgrade, it starts to fatigue and crack from the bottom up, and that's a structural failure rather than a surface wear failure. So stepping through what we do for mechanistic imperial design, ME provides modeling of the strains at the bottom of the pavement structure. So you choose a layer thickness, H, and select corresponding material properties in terms of layer moduli, E. Then you use a mechanistic model to simulate a load event. A single tire is shown here, but any load configuration can be modeled. Then the mechanistic model computes tensile strain at the bottom of the AC, this horizontal strain at the bottom of the AC, to empirically predict initiation and growth of a bottom-up crack. Step 4 of the mechanistic model also computes the vertical compressive strain at the bottom of the subgrade to empirically predict structural rutting. The M part of the ME design is the mechanistic computation of the strain. The E part is the prediction, is the empirical prediction. The newest pavement design methods contained within AASHTO MEPDG manual helps us calculate these now with the computing power we have available. After the process makes its performance predictions, how can the designer then adjust thicknesses and evaluate if the proposed structure may be over or under designed? What tools can we use to optimize pavement design? So perpetual pavement evaluation per road kind of filled this breach. Perpetual pavement design can be thought of as a subset of ME design. Again, we still define the thicknesses and the layer properties of this at the start of the process. We also define loadings in the same way. We use mechanistic model to compute the strain levels at the bottom of the structure, then use a per road tool as an enhanced layer analysis of the design. The difference is that rather than predict the development of cracking, we recognize that the material has an endurance limit, and that if we keep the strain, the horizontal strain and the vertical strain, below those endurance limits, we keep the strain from propagating bottom-up cracks and structural rutting. Okay, the history of endurance limits. In 1972, Professor Carl Monosmith theorized that asphalt materials had an endurance limit, and he estimated conservatively that it was about 70 microstrains. Jump forward to 2001, when he and some colleagues were involved in I-710 reconstruction in California. They used the 70 microstrain standard as part of their perpetual pavement design. Using the value resulted in 13 inches of asphalt pavement being placed over rubberized concrete in a heavily trafficked corridor near the port of Los Angeles. This is a classic example of perpetual pavement by conversion, which we'll talk about more. In 2002, the APA recommended using conservative values since no new design criteria had yet been developed, and it was believed to be conservative, that 70 microstrains. In 2007, this NCHRP report, the National Cooperative Highway Research Program report 9-38, study concluded that mixes with unmodified binders could use 100 microstrains rather than the 70 conservative that we'd seen in the past. And if you use polymerized asphalt for the horizontal strain, you could move that up to 250 microstrains. That same study also discussed that field conditions would be less severe than the lab, and therefore even these were probably likely conservative numbers. In 2007, MPDG software added a placeholder for perpetual designs and recommended using these same microstrain limits. And finally, in 2008, a study of full-scale sections of the NCAT test track demonstrated that measured strain could, at those levels, could far exceed the lab values and still be perpetual. This will be discussed in the next few slides. So this is a typical pavement cross-section. We need a good, well-understood foundation that considers drainage when the structural value of the subgrade is highly moisture sensitive. We also need to consider the cracking potential of the base layer. So we need to use a fatigue resistant AC at the base layer to enhance the crack resistance properties by increasing the asphalt content often, or maybe using polymers. Then we need highly rut resistant layers in the top of the pavement structure to withstand high compressive and shear forces that can cause surface mix to rut because of the mix, not because of the structure of the pavement. Stone matrix asphalts are sometimes used at the surface to improve the durability and rutting resistance of really highly stressed pavements. The various hot mix asphalt lift thicknesses and total pavement thicknesses will vary depending on conditions, but a working range for proven perpetual pavements has generally varied between 8 and 14 inches. You can kind of keep that in mind as we go forward. So NCAT, the previous plotted its test track information, and what do we got? Every section that they plotted, and I won't go into this very much because it'll just take a lot of time. But anything that plotted to the right of this non-fatigue slope did not have bottom-up cracking failure. And the gap between the two sections here is basically the 55th percentile factor used for safety between the two groups. When we design perpetual pavements, we have good, and anything to the right did fatigue and had fatigue cracking. So we're starting to understand that the strain limits are about what we thought they might be in the 200-250 range. You may also notice that one section is nearly aligned with the vertical axis. This section here, in this case, it's called well, it's to the far left. That is a section of the original test track that had 24 inches of asphalt over very similar foundation layers as the thinner 9-inch section that's shown here. So it had similar performance. All these pavements to the left of the fatigue line endurance limit are perpetual. So it illustrates that in the case of the 24-inch section, it was highly over-designed. This is what we're trying to reasonably evaluate in perpetual pavement. So NCAT had all this information from its test sections, but it also had all these years of actual perpetual pavements that they could, all the information from the APA perpetual pavement awards. So this plot, like the earlier plot, has cumulative percentile versus strain levels. You can ignore the dashed line. These dashed lines are failures of non-perpetual pavements. So these are all perpetual pavements from Iowa, Montana, Oklahoma, the second one in Oklahoma, Kentucky, Virginia, etc. This illustrates that the value of the information that was gleaned not from the test track, but from the APA by performance per pavement population is very critical. NCAT plotted its test track predicted tensile strain and then compared that test track prediction against the actual perpetual pavements. So these certified perpetual pavements are in this no fatigue zone. The most conservative curve, not surprisingly, comes from the thickest section, this Iowa section, the purple section. That had, I think, 21 inches of asphalt, where the Montana section had 7.5 inches, I believe. Every other section in between these two, all are on the good side of the non-fatigue line, and they're all perpetual pavements. So it validated the test track criteria and helped us forward the per road design model. Much less attention and research was focused on vertical strain criteria to control rutting. Here again, the Asphalt Pavement Alliance proven by performance perpetual pavement information was helpful. These same sections that we have validated below are in the before the same sections were used to validate the cracking criteria above when used to determine the vertical compressive strain limit. This plot shows that the 50th percentile strains at in each section, in all cases for these perpetual pavements, these actual perpetual pavements, if they fell below 200 microstrains, they were perpetual and didn't have any severe structural rutting. So based on this data, it appears that 200 microstrains at the 50th percentile will prevent structural rutting. And so our predictive criteria for judging pavements and structural rutting was shown to be valid, and it can be used to judge whether a pavement structure will perform perpetually with respect to structural rutting. This is just a plot of each of the multiple, the information that was gleaned from the APA perpetual pavements. Note the wide range of all different types of foundations, all different types of roads built over stable and stabilized and unstabilized subgrades, etc. There are many paths to be taken to perpetual pavements. The red line indicates the total depth of asphalt. Again, there's a wide range. The two extremes on the left are Iowa at 21.5 inches and Montana at 7.5 inches. I was right or 7.35 inches. Everything else is in between these two extremes. In practice, when the properties of these pavements are evaluated using per road, it also shows that some of these pavements were actually over-designed, like the Iowa example. Per road analysis can help get to an optimized design. So an idea is born. Recognize new pavements, since we have this per road endurance limit model, we can recognize new pavements designed to be perpetual. In 2015, when our state DOT state pavement engineer, Jeff Olmeyer at the time, observed that when we were building our second major crack seat and overlay project just south of Seattle, that the 50-year design life used for the pavement design resulted in a pavement that he believed would prove to be perpetual when tested against the microstrain design criteria validated by NCAT that we just talked about. So per road endurance limits design software could be used to validate any given pavement design designs resulting strains at the bottom of the pavement. Pavements meeting the microstrain criteria could be labeled perpetual. Validating designs via Pave Express and per road can also be allow designers to optimize the pavement design for materials and cost and long-term benefit. With per road validation, the APA created a new perpetual pavement award criteria. We can now recognize these pavements that are built recently. Knowing that the proven design techniques were being used by WashDOT, and with the advent of microstrain endurance limit analysis, ease the use of, by using per road, the pavements could be validated by a real analysis of the endurance limits. When the tools are with all the tools that are now in place, and I'll show you kind of where they're at, the Asphalt Pavement Alliance took on the challenge of recognizing pavements that are being built today to per road criteria. Again, given that per road was added to the APA's AASHTO 93 based design tools in Pave Express, the ability to meld and evaluate all the design criteria in either ME or empirical designs through per road analysis was provided, and the opportunity to expand the APA promotion of perpetual pavements was instituted. In 2019, the APA, again, NAPA, SAPA, and Asphalt Institute representatives there began discussions on development of an expanded awards category so that designers working today could be recognized for their efforts and vision. So by design and by performance perpetual pavement awards were tested in 2020 using Washington State pavements, thankfully, that were recently built, one in 2011 and one in 2016. With successful criteria established, the awards were widely adopted in 2021. While the by performance awards validate good experience-based design and good stewardship of the highway over the years, the new awards those awards could not be ascribed to today's WashDOT employees, nor could they really recognize the contractor who built the pavement because they're very old pavements. Knowing that proven design techniques were being used by WashDOT, and with the advent of microstrain endurance limit analysis through per road, we could now use that information to recognize pavements that are being built today to per road criteria. So if you haven't ever been on Pave Express, there's lots of training tools online. It's a free online web-based design catalog based on AASHTO 9398. And it's been validated by several other state design engineers or design professionals. And it, again, free, lots of training tools. There's PAVE instructors on it. And this platform helps us to be able to integrate the per road criteria. Using the Pave Express tools, pavement design variations can be tested in many combinations. So you can use the Pave Express design to mix and match pavement thicknesses, etc. And the resulting design can then be validated using the per road design parameters are embedded right in the same software. Pave Express already has per road design integrated. Expanding Pave Express to be able to approximate, it basically helps us approximate ME designs by using the old AASHTO designs and allowing for per road analysis. Note that Pave Express has in-depth training videos. Pave Instruct per road is section 6. Using the Pave Express tools, pavement design variations can be tested in many combinations, and the resulting pavement can be means tested against per road microstrain design limits. This recognition illustrates a key function of per road. With Pave Express, multiple iterations of pavement design can be studied quickly and subjected to final design analysis for per road. And that can illuminate whether the design can be tweaked to enhance the road to a perpetual pavement, or it can even identify when a road has been likely over-designed. So in 2020, as I said, the APA Award Committee defined the critical criteria for 2 new pavements. Perpetual pavement by design is a completely new pavement from the subgrade up, and perpetual pavement by conversion is existing pavements utilized in design construction to strengthen and enhance the renewed pavement structure. All the tools, as I said, are already integrated into Pave Express, so this can all be done, from the pavement designers' web-based design tools. So now there are 3 perpetual pavement award categories: by performance, kind of the traditional one that we talked about early; by design, which has been validated by NCAT and has the information gleaned has been put into per road, or helped to validate per road; and by conversion, again, the same thing, converting an existing, can be evaluated, converting an existing pavement through rehab into a perpetual pavement. That's a by conversion award. The new award nomination process, the owners submit the pavement design section that they use when building the road, and the accompanying underlying design inputs, and those designs are then transferred to NCAT for independent evaluation using per road. So it's not done by us, it's done by NCAT to make sure that the road does meet perpetual design standards. If the design passes the per road criteria, the limited strain criteria, it's judged to be a perpetual design. So here's just a screenshot of the new by design award nomination forms. And it's, again, only the 2nd year that we've been awarding those because we were the test bed. Washington has 2 perpetual pavement by designs. The first one and then the one we got last year, well, the other states started picking up the award by nominating their projects. So just as we saw in the NCAT evaluation of the many by performance perpetual pavement award winners from the past, these newly minted perpetual pavements by design again illustrate there are many ways to build a perpetual pavements from the ground up. You can see a lot of different layer thicknesses, a lot of different subgrades, a lot of different interim materials being used, base materials, etc. All end up giving you limited strain at the bottom of the pavement design. And as we talked about, the theory is that it's about between 8 and 14 inches. These ones that have won the initial design comparisons are, the asphalt is 9.25 to 14 inches thick. So about what was predicted by per road. What else do I want to say there? That's basically what I want to say. So using the Pave Express tools, pavement design variations can be tested in many combinations, and the resulting pavement can be means tested against per road. Washington gave out its initial proof of concept award in 2001 and followed the next year, this year, or in 2002, 2000, I'm sorry, 2021, and we gave our second award out in 2022 in November. And this is just a few screenshots of that process. The award winner this last year was SR 520, about a 4.5 mile section of road in the southwest region of Washington State. And the difference here is this, we get a fancy new obelisk that's suddenly different from the original, and the contractor who actually built the job can be recognized and awarded, adding value to the new program for our membership at least. We don't build a lot of brand new pavements in Washington State. I hesitated adding this cross section because of the lots of detail here, but doesn't illustrate that we're basically building widening new pavements for the most part. This is an extensive widening project, 1 lane and 10-foot shoulder in both directions. The new lane structure has geotextile for subgrade, gravel barrow, which is imported uncrushed gravel at the subgrade level, 8.4 inches of crushed base course, our 1.25 minus material, and 9.6 inches of asphalt in 4 different lifts using PG 64 minus 22 equivalent and 1/2 inch mix, including the final wearing course of 1.8 inches. So per road WashDOT, using the structural design they developed using Darwin, which is an advanced AASHTO 93 design software, enters its information into per road. The Poisson ratios and seasonal layer moduli are all calculated from the information provided, blending mechanistic design with empirical design in the process. And again, known design data is entered into per road in order to for the tool to calculate the strain at the bottom of the pavement layer and the top of the subgrade. So all the ADT is put in, axle loads, etc. All the stuff that you've actually already know because you've done your design in AASHTO 93. And these are the design criteria for a per road by design and by conversion award winner. The cumulative strains that we showed earlier, and the vertical strain, compressive strain for resisting structural rutting. So those are the kind of the gatekeepers. And so all that's put into the per road design by the National Center for Asphalt Technology. They run it through their software, which is again available at Pave Express. And if you pass all those criteria, you've got a road that's going to be perpetual. Per road validates the tensile strain at the bottom of the pavement to ensure that structure will be sufficient to resist bottom-up cracking in perpetuity. And similarly, the vertical compressive strain never exceeds 200 microstrains, which we talked about earlier. Therefore, the pavement will not experience structural rutting. This analysis can be done by the nominee using the integrated tools in Pave Express and Pave Per Road, but it's also, to get an award, it actually has to go through NCAT to validate it. So here we are with happy award winners. Again, we've got the Secretary of Transportation, the WashDOT Regional Administrator, State Pavement Design Engineer, and this time, you'll note, we've got the contractors that actually built the roadway accepting an award, which gives it extra value. We get to recognize both WashDOT and Lakeside, who built this. This is a 4.25 mile stretch of highway near Vancouver, Washington, constructed in 2017. Just a couple of pictures of it. Built this new lane and this new shoulder and then overlaid the whole roadway. But because of the design that was used, it's a newly built or nearly newly built project that should be perpetual, or is perpetual. It's not, again, it's not a particularly unique, especially unique road section, other than the new construction is kind of rare in Washington State. The point is that WashDOT design can be fully evaluated during design for an intrepid designer, and the optimum design can be evaluated. NCAT independently then validates the final design for an award to be won. Same thing for a conversion now. We move to the other category, the second new category, by conversion, evaluating the transformation of an existing failing and obsolete road that is treated in place and built back better. Similar nomination form, new obelisk, fairly straightforward process. For it to be a converted road, it has to still be in use but structurally deficient. So you're adding thickness to meet a new design criteria, or it could be distressed and failing. Perform rehab to deal with distress. And what we have used is crack seat and overlay. Others use rubbleized, treated bases, etc. Reflective cracking is a major problem if not considered, especially over an old concrete pavement. So this is why crack seat and overlay and rubbleized pavements are pretty well defined nowadays. We test the design for the perpetual pavement criteria against per road. The initial pavement by conversion awards, again, we have two. And so we were a little bit ahead of the game because we were the test bed. But then I see that Illinois got two, and I didn't know that was possible. But it actually is they won both state pavement and a county pavement, both won an award. And I didn't know that was possible. I thought it was only one per year, but evidently it is. So everybody can catch up. The by conversion perpetual pavements are bound to be even more diverse in how they were built, because for these awards, you need to start with the existing pavement and build a new structure using the existing materials as the base. Notice that Illinois Highway 4, for example, I'll talk about it a little bit later. It was originally only 4 inches of asphalt on subgrade, and it failed. This is the Illinois 4. This 4 inches failed, and they put a 6-inch unbonded concrete overlay on the top of it, and that subsequently failed. Mostly due to severe blowups. And so the solution was to rubbleize the concrete and pave it over with 5 inches of super pave hot mix asphalt in 2 lifts. And therefore it becomes a perpetual pavement by conversion if it meets the per road design criteria. And it did in this case. Again, this varies almost exactly as we predicted, between 8 inches and 12 inches of pavements to get to a place where the pavements are perpetual. Okay, so our perpetual pavement by conversion award winner was southbound I-5. My poster there, our most heavily used interstate, Interstate 5, 200,000 ADT, originally constructed as concrete pavement in 1965. Various rehab projects over the last 20 years of slab corner repairs, full panel replacements, dowel retrofitting, diamond grinding, surface smoothing were no longer effective, and ride roughness was skyrocketing. It continued ride deterioration due to uneven concrete slab support. We used plain jointed concrete in the original construction, so there were no dowels originally. That's why we had dowel retrofits. On this project, the worst 2.7 miles of I-5 southbound was resurfaced in 2015 via crack, seat, and overlay process. The resulting composite pavement meets per road perpetual pavement design criteria and therefore qualified for a by conversion award. This project was the impetus of the by conversion perpetual pavement award. As I talked about earlier, the state pavement engineer, upon completion, said not only did this crack seat and overlay solution save in excess of 25% versus a concrete replacement in its life cycle cost analysis, it was also designed to be a perpetual pavement. And he said, we should get an award for that. And the Asphalt Pavement Association or Alliance eventually agreed. Real quick, this is just south of Seattle proper, just east of SeaTac Airport, southbound. Southbound I-5, just prior to beginning the process, the IRI was routinely in excess of 175 on this inside lane with dangerous patched sections. And the design that the state came up with was crack and seat the existing concrete, and then put in 8.4 inches of mix, eventually 4 different lifts, 2.1 inches each in these lifts over the entire roadway. Here the project, you've seen the detail. So here's the detail of the cross section, which I just talked about, but the various lifts, what we did was crack and seat the pavement and then put these lifts in on successive weekends. It was very successful in closing the project down and having the whole thing completely redone in 4 successive weekends, or four weekends, because of rain, they weren't successive. Here's a close-up of, let's see, what do we have here? All the crack and seat process could proceeded across the lanes when the pavement leveling course could also proceed across the lanes. With 3 lanes closed, the paving contractor could often use echelon paving, eliminating multiple cold joints in the process. So we close up to 3 lanes on Friday night and begin the process, cracking and seating. And then as those slabs are seated and lanes are completely cracked and seated, we start the multi-lane pavement right behind it. So basically on Friday night, it was a rough as a cob concrete pavement. And by Monday morning, the first layer or the successive layers made it like very smooth. It was like magic. If you don't know about crack and seating, this is what we do. The WSDOT design outline was developed using the Strategic Highway Research Program's R22 project, using existing pavements to achieve long life. So you basically use a big guillotine hammer to crack the existing pavements. And you can see kind of the resulting cracking pattern here. You can see why there's lots of distress that can't really be fixed in any good way anymore. The Band-Aids weren't working anymore. So we crack these into 4x6 panels. Then we test to make sure it's cracking all the way through so that we're getting some relief cracking, but also retaining a lot of the structural value of that old concrete. This is done earlier in the design sequence. And then we seat the cracked and seated, concrete with a 35-ton static roller to seat it into the subgrade below. So then you've got a very good base to pave over the top of. You can see the drop hammer scoring here in this picture, and we're starting to pave. State-of-the-art paving, MTV, state-of-the-art super paved materials. With the cracked and seated surface cleaned and tacked, the initial layer of leveling asphalt is installed, followed by the 3 successive lifts to get to 8.4 inches, as I talked about before. The finished pavement had an average 49 IRI score, which is very smooth, with average compaction on the wearing course exceeding 94%. It's a very smooth ride, perpetual pavement. And because we were able to close the freeway over 4 successive weekends, this contractor had a peak production of 650 tons an hour. He put down over 60,000 tons of mix over 4 weekends. In order to create the best possible final product and minimize disruption, all 5 lanes of wearing course were paved over. The last wearing course was paved over a single weekend, which is what can be done with asphalt, quick paving. Okay, there's the final project, still performing very well today. Just another view of it. And here we go again, the Secretary of Transportation, the Office Pavement Engineer, the Northwest Regional Engineer, and their folks are there, and the contractor can be recognized too, Icon Materials in this case. The converted pavement is performing well 6 years later. The WSDOT crack seat and overlay process, as refined in this project, was used on a larger sister project on the northbound lanes the next year, which had 100,000 tons on it. The crack seat and overlay is currently the preferred concrete rehab process when other options are exhausted. WSDOT plans to convert 260 lane miles in just the next decade. WSDOT's life cycle cost analysis routinely shows a 25% savings, and they're perpetual pavements. Well, I am playing.
Hi, I'm Tom Pierce with the Washington State Department of Transportation. In summer 2017, we are repaving 4 miles of northbound I-5 between SR 516 and SeaTac and South 170th Street in Tukwila. It's all part of our larger effort to revive I-5.
The interstate's concrete surface is more than 50 years old. Some of the parts are starting to wear out. We've got broken concrete panels and others that are moving because the soil underneath has given out. They only move fractions of an inch, but if we just put asphalt over the concrete panels that are moving, the new asphalt would quickly crack.
To avoid this, we're using a process called crack, seat, and overlay. This allows us to condense a couple of years of individual panel replacement work into a few long weekends. Here's Here's how it works.
A panel breaking machine cracks the concrete. The one our contractor is using has a 12,000-pound blade. Every 3 or 4 feet, it drops like a guillotine onto the concrete panel, cracking it. Watch the rubble in the road bounce every time the blade hits. Even 20 or 30 feet behind the truck, you really feel the ground jump, and it's loud, even wearing ear protection. Next, a compactor presses down the broken concrete. This is basically a giant block of steel that weighs 35,000 pounds with huge rubber wheels that make sure the concrete is firmly seated into the ground so it will be a stable base for the new asphalt. Once that's complete, the paver comes through and paves the first layer of asphalt. It moves very slowly, putting down a couple of inches at a time. It takes a lot. Just one truckload of asphalt will pave a section 1 lane wide and about 100 feet long. And that's just the first layer. Finally,
You kind of get the idea there. I didn't, we're running short on time, so I want to keep going. Of course, I love Washington Perpetual Pavement Awards, but one of my favorite awards this year was the winner of a county road in central Illinois that I talked about a little earlier. Why was that? Because it's highlighted a previously unheralded design that they have dubbed the Oreo design. Platte County converted a dangerous, deteriorating 5-mile section of Monticello Road, County Highway 4, from a 5-inch white topping to a multi-layer asphalt top roadway. This portion of the county road is expected to require only minimal upkeep in perpetuity, and the very dangerous concrete blowups have been completely eliminated. You can see they use rubblization rather than crack and seat on this project. According to the Platte County engineer, rubblizing the existing concrete road and using it as a base for the new asphalt pavement prevented the failing concrete white topping material from ending up in a landfill, which is key. There are other financial benefits to consider with increasing costs both now and in the future. The county highway engineer says the highway agencies should at least explore the concept of perpetual pavement in all future designs. The ability to limit the cost of pavement maintenance should be appealing to all highway owners. Article highlighting this project is also referenced in the FHWA study of perpetual pavements. Anyhow, this report even cited perpetual pavement's contribution to reducing and depleting ozone, reducing the depletion of ozone, fossil fuels, water, and global warming, smog, and exotoxicity. So, you know, a lot of things are accomplished in not having to tear that pavement up, take it to a landfill or reprocess it someplace else and rebuild the road from scratch. So in Washington State, the crack seat and overlay designs have been found to save in excess of 25% of life cycle costs over a 50-year design and recycle in place. Perpetual pavements are widely recognized across the U.S. The APA awards focus not only on existing but proven pavements now. The new emphasis on perpetual pavements by conversion and design is the new focus. We must consider existing distresses, and the per road endurance limits help you with the design. Perpetual pavements can be designed using mechanistic principles. Per road and Pave Express are effective, free, and widely available design tools that incorporate strain distribution design analysis. And perpetual pavements by design and conversion are proven to be very cost effective and can be optimized during design. And I think that is the end. If there are any questions, I guess now is the time. Tom or Mike, whoever's running the program, if you want to take back over, I will stop sharing my screen.
Thanks, Dave. Thanks, Dave. Tom had to step out, so I'm Mike Skinner, the Director of Engineering here for the Colorado Asphalt Pavement Association. And so I'll just share with you, we did get a couple of questions. One, will the information be shared or available? Yes. I think Tom mentioned when we started the webinar that we record this webinar. Give us a couple of days to process that, and then it will be uploaded into our CAPA technical vault that you can find on the CAPA webpage. So if you're taking notes or want to go back and look at it, it'll be available. And then Dave, there is one question here from John Young over there in Hawaii. Did you mention that the award is not only for DOT roads, but are they also available for local or county roads?
Well, I saw that County Road 4, Platte County. Like I said, it surprised me a little bit that they got 2 awards in 1 year. But yes, county roads or city roads, whoever have in any of the categories are also available. It's just you have to have, for the older category, you have to have good pavement management history. For the new ones, you just if you have a designer that uses Per Road and Pave Express, it's pretty easy to do, but you have to submit the design. But yeah, county roads, city roads, ports, et cetera, can also apply. They haven't so far, other than this one example that I just showed you. But I have one in Spokane County that I'm going to have processed next year, I think, because they did a reconstruction on an old road that is really impressive.
Excellent. Thank you. Well, as I wrap up here in our last 90 seconds before we say goodbye, I'll share with you Colorado perspective and what we have here. We have Colorado has been awarded Perpetual Design Awards, as Dave may have mentioned, as those are facilitated through NCAT. So we see they work in all environments across the country. We've seen them over on the western slope of Colorado, and they have competed and won under that category by performance. They weren't designed that way, but they've been long lasting and performing. That's in CDOT Region 3, and then CDOT Region 2, which is the Eastern Plains portion of Colorado. We, CAPA, have put together nomination packages for 4 or 5 roads that out there that meet the qualifications, and provided those to the DOT to submit. So we're waiting to see what they do with those. But we do have several perpetual by performance projects here in Colorado. And surprisingly, we have one city local agency, the city of Aurora. They designed one of their roadways, ILIF, which is a major collector for the city. And it's pushing 20 years of performance right now. So we're seeing great success with Perpetual Pavement. So I'd like to thank everybody for being on with us for this webinar today. Dave, thank you for your expertise and sharing your knowledge of the program in general, and why Perpetual Pavements are so successful. So like I said, this will be recorded if anybody would like to come back and have a follow-up or catch something you didn't miss. Thank you all for joining us. Have a great day.
Thank you, everyone.
Nice job, Dave. Thank you.
Thanks. I know we rushed through it a little bit, but I appreciate it. Thanks.
It's all good. Okay, we'll talk later.
All right. Bye-bye.